Right now, we're going to talk about prime numbers and how to factor numbers. A factor divides a whole number, leaving no remainder. Right? Now, there are a lot of different definitions, but this is a pretty good one. A factor divides a whole number, leaving no remainder. So if we have the number 12, we know that 12 has a factor of 2 because 2 will divide into it, giving us no remainder. If we took 12 and divided it by 5, remember the nice old days of doing that division, we get a remainder. You can do the division, it just means that 5 is not a factor of 12. Now, what in the world does it mean for us to know a factor? Well, it is great to be able to go into a mathematical microscope, and that's what factoring a number does. It breaks the number down so you can see all the, not necessarily the atoms and the molecules, but you can see all the factors that make up that number. So important for a lot of skills later on in mathematics. It's one of those sort of mathematical jumping jacks. By itself, not too earth-shattering, but you put it together with some other stuff and really, really important. So let's take a look here. If we have 625, we wanted to come up with the prime factorization. Now, prime factorization means we're going to have prime numbers in our factors. Not just numbers that divide exactly, but the prime numbers. Numbers, again, when you have a prime, the only other factors are 1 and itself. I am a favorite fan of the factor tree. I like to go through and break the number down, and this is really just a way to keep organized your information. I like to say, well, I see it ends in a 5, so I know that 5 is going to be a factor. So literally, you think of what number you're going to get when you divide by 5. And you don't have to think for very long. You can actually do the division and figure it out. That's going to be, if I did it correctly, and I didn't. There we go. I think it should be 125. I know that doesn't look too neat, but it should be 125. 5 times 125. So it's called a factor tree because it sort of branches out. Now, 125, again, ends in a 5, so we know that it has a factor of 5. Another way, remember, to check for some of those divisibility rules, 5 plus 2 is 7, plus 1 is 8. It means it can't be divisible by 3. It's not even, so it won't be divisible by 2. So it looks like 5 is our shot. Divide 125 into 5, and that will go 25 times. Now notice that I'm going to break the 25 down again. And as my tree gets down, my numbers get smaller. It gets a little bit easier to break it down. So I have 5, 5, 5, 5. Well, that's a little creepy. That my prime factorization is 5 to the 4th. And you always want to use your exponent knowledge to write any repeated factors to condense it a little bit. All right. Now that was a pretty good one. Let's try another one. Let's say that we have the number 216, and we want to do our prime factorization. It's even. Hopefully you're thinking we can divide by 2. Again, 108. That's not prime. 2 is prime. And we can break the 108. Again, it's even, so 2 divides 108 gives us 54. Again, breaking that number down. Now, 54 is even, so 2 goes into 54 27 times. My tree's getting pretty long here. So now I'm going to break down 9 times 3 is 27 and break down my 9s. Wow, it's a pretty long tree. So I have here, again, helps stay organized and neat, 1, 2, 3 factors of 2, and 1, 2, 3, 3 factors of a 3. And that's my prime factorization. You can see lots of 2s, lots of 3s, lots of 5s, lots of 7s. You'll get really sick of them if you practice. And that's what you better do. Practice.